Good morning, class. Hopefully you guys can hear me. Let me know if you can hear me. Okay, so let me share my screen and let's get into it. Okay, so let's start with the land acknowledgements. We acknowledge we're hosting the lands of the Mississauga of the Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay. Somebody's trying to get in. Who's trying to get in here? Okay. Okay, so let's go down to what's going on for today. Today is Friday, July 19th, day 14. Wow, that means we're almost done. Day 14. I said there's like 18 days, right? So, well, I guess technically it's 19, but you'll know your mark by, I mean, of course, technically over 18 or unofficially over 18, but technically over it's 19. Okay, so what's going on today? Okay, you're gonna watch here step by step. You guys are going to work on the collimating activity. Okay, it's open today. It's due on Monday, so that means you have the whole weekend. Okay, it's a collimating activity. That means it covers the entire course. You have written responses, just like when you have the tests, are written responses, right? So written response, you're gonna have to, submit it like you submit the test where you have it's a PDF, take pictures or make it scan it or whatever, but it's a PDF you submit. Okay. So that's what you're gonna work on. But before you work on that, I started the lesson yesterday where yesterday what I do, I talked about simple interest and compound interest, right? So I need to talk about preset value. And today I have to talk about preset value in annuities and preset value of annuity. Okay. And I think the worksheet yesterday will cover all this. And then when I'm done covering all this, there is a quiz related to simple interest, compound interest, annuities. Here's a quiz. Okay. So again, the quiz is like you get two attempts, but you need to, we're gonna go through these, we're gonna go through this part here because we didn't finish that yesterday. And then you can work on the quiz. Okay. And then the quiz, and then from after the quiz, I would work on the collimating activity. Okay. Which again is due on Monday. So you have the whole weekend for this. This quiz is due tonight. Okay. I think it's 10 questions. Okay. I also put a note here if you're thinking about dropping a course, uh, maybe think about it on Monday, not today, but on Monday, think about it. Okay. On Monday, we should have all your marks in as far as unit 3 test and unit 4 test. Everything should be marked, and you'll see what your mark is before before working on before the Monday or before this deadline to drop the course. Okay. Okay. So I want to make sure I see what you guys see. So I'm going to come in as a student, making sure these links work. Okay, I'm coming in as a student. Let's look at the collimating. There you go. Collimating activity. Okay. It's available now. Okay. But we're not going to work on it now. You guys are going to work on the lessons for today. Let's make sure the quiz works for today. Yeah, the quiz works. Okay. Let's see what else. I believe you have the worksheet practice if you want to practice for the quiz. Okay, practice questions. Okay, it's there. Okay, so let's go into content. And let's go continue what we were doing yesterday with preset value and annuity. So we're going to discrete functions. So yesterday was the 18th. So we finished the compound interest. And that was lesson. So let's look at preset value. Let's look at that. There's a video for that, so we're gonna go through that and break it down. Make sure you guys can see it full screen. Okay.
So it's your seventh.
Okay, can you guys hear the video? Just want to make sure. Okay, good. So here we go. So we're going to talk about preset value.
17th birthday, and your parents got you into the living room and they said, "Well, son, happy birthday. We thought we'd get you a gift." And you're like, "Oh man, I've always wanted a gift." And they're like, "Well, I hope you enjoy it. It goes vroom vroom and it'll get you from here to school." And so you open up your gift and this is what you get. A brand new old car. And you're like, "Oh, thanks, parents. I really like this car." And so you take it out and it breaks down right away. And so you think to yourself, "Man, I wish that 10 years from now I had my own car." And so you think, "Well, if I want my own car, I need to save enough money." So you say to yourself, "All right, 10 years from now, or even before that, let's say 5 years from now, I want to save $20,000 to buy my own car." So you go to the bank and you ask them, "All right, if I put money into a savings account, how much interest do you give?" And they say, "Oh, well, we charge 4% annual interest." And so you're like, "Sweet. So if I put money into an account at 4% annual interest, happens to be compounded monthly, I want $20,000 5 years from now. But how do I know how much money to put in now so that 5 years from now I have $20,000 to buy this brand new car?" That is what we're looking at in this lesson. Today we're talking about present value. Present value is essentially the amount of money that you need to put into an account so that you end up with some end amount.
Okay, present. I was saying preset. Sorry, I meant to say present. So present value. Okay, that's what we're looking at. Present value. So this is, you're going to kind of see this formula looks similar to the compound interest formula, right? Like you can see in the end, and remember the compound interest formula, you had the future amount, you had to pay back, you had P was your principal, I was your interest, N was the compounding periods. So it looks similar. Okay, I mean, we're going to use this formula. I shouldn't say look similar. This is the formula that we learned for compound interest. So you're going to use this in a way that we're going to look at present value. Okay, so watch.
These questions will give you the end amount, and you need to come up with the present value. So let's just start with our original formula. Remember, compound interest formula states that the total amount is equal to the principal times 1 plus I to the exponent n. And we've discussed what all of these things mean. A is the amount at the end of duration, P is our principal, I is the rate of interest, and n is the number of compounding periods. So if we know the total or end amount, and I'm looking for the principal, or the amount that I need to put in, what's a formula that I could use to find that?
Okay, so let's look at that again. If we know the amount of the future, and we're trying to find the amount for the present value, right? How can we figure out the present value if you know the amount of the future? Well, what you can do is basically use this formula that you have there, right? So this formula you have here, right? If you rearrange it and you want to find the present value, so now I want to get P by itself, right? If I want to get P by itself, then I'm going to have here A divided by 1 plus I to the power of n, right? Now I know the present value, because the present value is almost like when you go back to the compound, this is like the compound interest formula that we learned yesterday. It's like we need to know the principal value or the principal amount, which is the starting amount. Principal amount is the starting amount. Okay. It could also can be considered the present amount. The present amount, and we want to figure out what is the future amount. In this case here, we already know what the future amount. Maybe the future amount is I want to save $5,000 in the future. That means I need to know what I need to start with. And if I'm putting money in the bank to get interest, so the money builds up, then I need to know what the interest should be, and I need to know how many compounding periods there should be in order for me to know what's my present value that I'm gonna need to put in the bank in order to get $5,000 in the future. Okay, so that's what we're looking at. Okay, so here we go. Let me just clear the screen and continue.
Well, let's isolate for P, and we'll see what we end up with. So let's write this formula back out. A equals P times 1 plus I to the exponent n.
I'm just going to fast forward because we know. Okay. He's just doing cross multiplying, and then what happens? You're going to get. Oh, the other thing too. He's doing some fraction stuff. So if you remember your fraction rules over here, he's showing you here. These are fraction rules. If you have 3 to the power of negative a number, like say for example 3 to the power of negative 4, then that's the same thing as saying 1 over 3 to the power of positive 4. Okay, so okay, that's what he wrote there. Okay, so remember, this is what I wrote, right? I'll show you what I wrote, which is the same thing. We got to make sure you guys understand that it's the same thing. I said when you isolate P, it's going to be A over 1 plus I to the power of n. Now, what they showed you here is that it had a negative exponent. See that? The negative exponent is the same thing as this. Okay? And that's what we're showing you over here. Understand that, right? So instead of having it as a numerator, they put it as a denominator, like, and basically have the negative exponent. Okay? And that's how you get the present value. I mean, it's the same formula. It's just how they wrote it as a negative exponent, but that's what the negative exponent means. Okay? So remember that. I think he's going to talk about that. So let me back up so you can hear him say it. So it's not just me just saying it. So here we go.
Exponent n in my denominator here. Well, that would be the same thing as me just writing A times.
Right? So like here's the exponent right here. It's the same as this one over here. And now he's rewriting it with the negative exponent.
1 plus I, but to the exponent negative n. And that's what my principal would equal. So this is very, very similar to my original formula for compound interest, where A equals P times 1 plus I to the positive n. But when we're looking for the principal, then exponent on the 1 plus I turns to a negative. So from here on in, when we talk about present value, we're going to refer to the principal as present value, and the total amount will be referred to as future value. They are used interchangeably.
Okay, remember that. We said the present value is the principal amount when we were talking about before, and the future amount, right, is the amount. Okay, or future value, we call it amount. Okay, so here, principal, refer the principal as present value and the amount as future value. Okay, so when we write this formula, you're gonna have for the principal, you're gonna have PV, and for the amount, you're gonna have FV. Okay.
So you could use P or PV, and you could use A or FV, and they would mean the same thing. But essentially, present value is just equal to the future value times 1 plus I to the exponent negative n. And we could write that future value is just equal to the present value times 1 plus I to the positive n. If you're thinking about this, the future value is where you start, and then it can only grow, so the exponent's positive. But present value is you start at the end, and then it can only go down, which means the exponent has to be negative.
Okay, so just remember that. Okay, so your future amount, this one here, the future amount and the present value, like we said, it's similar to the compound interest formula where we said, I'm just going to show you the similarity so you guys can see that. So we said this was A, and this was P, and this was 1 plus I to the power of n, right? And then we're saying that it's this, what we're doing here is now we're trying to find the present value. So we can call this one the principal, but that's not what we're trying to do. We're trying to find present value. And then you need to know your future amount. And 1 plus I negative n. Okay. What we're doing now, since we're talking about present value, we don't use these variables here because, I mean, you could use it, but what we're using now is the PV and FV. Okay. But remember, they mean the same. Okay. It's just that we're talking about present value, then we're going to use this formula because we need to know the future value. And if we want to know the future value, and then we need the present value. This is all dealing when we're talking about investing. Okay. So that's why in the past, when we talk about compound interest and we're using that formula, that was for like loans. And for the most part, we're doing for like loans and credit cards or that kind of stuff. Here, we're talking about more investments. Okay. So let's get into more examples.
That's an easy way to think about it. All right, let's check out a couple examples. Example 1.
Okay, so here's an example, right? Where he's talking about investing, right? So you're finding the present value. Okay. So Kyle, who's in grade 9, wants to invest money so that he can buy a $1,000 computer by the time he starts university, which is 4 years later. So he's trying to invest money so he can buy something that costs $1,000 in the future. Okay. If he invests his money at 6.5% compounded semi-annually, how much money would he need to invest now? So if he can find something at the bank where the bank is going to give him 6.5%. Okay, sorry for that, guys. Give me a sec. Hold up, guys. Hold up. Okay, sorry about that. Sorry for that. Okay, so if he invests his money at some kind of account, maybe it's a savings account. No, most likely it's not a savings account. It's probably going to be some kind of mutual fund account. You guys will learn about that as you get older. Mutual fund account or some kind of account that's going to give him 6.5% compound semi-annually, right? How much would he need to invest now in order to get $1,000 in the future? So what we're going to do is write down the formula. The future value is what? $1,000, right? That's what we need in the future, right? Our I for the interest is 6.5%. So we're going to write it as a decimal, 0.065. N is a compounding, and it's saying it's compounding semi-annually, but we're doing compound semi-annually. So that means it's 2, but we're looking at 4 years, right? So it's going to be altogether 8. But then I have to go back to my interest. My interest, yeah, it's 6.5%, but it's compound semi-annually. That means I got to divide that by 2. Okay, so if I need to, now I'm looking at my formula, so my present value, okay, is going to equal to future value, bracket 1 plus I to the power of, remember, it's negative n, right? And how you can remember negative n, right, is that my present value is going to be less. So maybe that's another way to remember. If my present value has to be less than my future amount, right? Because my present value has to grow to the future amount. So if my present value, I'm trying to find my present value, then I should look at my exponent should be negative. Maybe that's how you can remember. If I reflip this around and try to find my future value and my present value is on this side, then my future value is a positive number, therefore my exponent is going to be positive. Maybe that's a good way to remember, okay? I'm just giving you tips to remember. So my present value is going to equal to 1,000 plus 1 plus I, and I is 0.065 divided by 2. I didn't divide it by 2, so, and then my compounding period is going to be 2 times 4, which is 8. Okay, and present value is going to equal the sum amount. Okay, I'm not going to do the calculation because we're just going to see it shortly on the screen, but that's how you would solve that, right? So he would need to invest this much money now in order to grow to $1,000 in the future. Okay, so let me play it out. Let me see. You know what? I'll just clear the screen. It should show the same thing, but I'll clear the screen and we'll play it out. I'll fast forward stuff so we can actually. There you go. There's your see, like I said, present value is going to have a negative exponent. Okay, there's 1,000. Okay, compounding period is, so it's going to be -8, right? Semi-annually, so my interest rate is divided by 2, like I said it before. Okay, so he's punching that in the calculator, and maybe we should see how you punch this in the calculator, right? Because you need to have a negative exponent. So you use your 1,000. If you have a good calculator, you can put everything in one shot. If you have a good calculator, right? Fast forward, and then to the exponent, that's your exponent symbol on the calculator, and then -8. So I have to put in $774.25 today in order to get 1,000, in order for it to grow to $1,000 in 4 years. Okay.
All right. So Kyle's going to need to put away $774.25 in grade 9, and 4 years from now, he's going to have $1,000 that he can spend on a computer, which will probably be 1,000 times better than a computer he would have bought if he bought it now. And who knows, 4 years from now, maybe that computer won't even be worth $1,000. He could probably buy 4 computers for the same amount of money.
Okay, so let's go to another example. Okay, here's another example. Okay, where okay, you're trying to find I. So now this is a little complicated. You're trying to find I. I is your interest. Okay, so you may have to do some manipulation with the formula. So Count Chocula, I don't know why you're using that person. Count Chocula borrowed $500 to buy a CD TV, which is Chocolate Deaf. I don't know why. Okay, Chocolate Deaf. You know what? I'm gonna play it out. Let him read it. Sounds a little ridiculous to me, but let him read it.
All right, in this example, we're going to be finding the interest rate. So it doesn't necessarily have to do with present value, but it's a good thing to practice anyway. Count Chocula borrowed $500 to buy a CD TV, which is a new chocolate deaf television. He agrees to pay $610 in a year and a half. So what annual rate of interest that's compounded monthly is the Count being charged by the person that he borrowed the money from?
Okay, so he read it out. So let's summarize it again. He's borrowing $500 today, but he agrees to pay in the future $610. He agrees to pay in the future, which is 1 year later. 1 year and a half, a year and a half. Just remember that's a year and a half later. So now we want to figure out what is the interest rate. Okay, so I mean, it doesn't matter which formula we use because we know the present value. We also know the future amount. So the only thing we don't know is the interest. It doesn't really matter what formula we use, but let's pull out a formula. Okay, so we can say, let's say future value, just to make things easy. Future value, and it says compounded monthly, right? So that's another thing to know. So future amount is 610. That's what he agrees to pay. The present value is he's borrowing $500. We don't know. We don't know. The interest rate, we don't know. The compounding period, we don't know, or we do know. It says compounded monthly. That means it's going to be, and then it's for a year and a half. The key is it's a year and a half. So compounding, so a year and a half is, so this is a year and a half, 1.5, but it's compounded monthly, right? So we're going to multiply 1.5 times 12, right? So that's going to give you 18, okay? And our interest is actually going to be divided by 2. Sorry, divided by 12. It says compounded monthly, okay? So when you write in the formula, right, you're going to have this formula. Say we're going to use the future value formula. Present value, 1 plus the interest, which is going to be I divided by 2, or divided by 12, sorry, my bad. And then our N is going to be 18. So what you want to do is basically rearrange this to get I by itself. Okay, so that's what the exercise we're going to do here. So he's going to show us how to do that. Okay, so let me just clear the screen. You know what? I won't clear the screen. I'm just going to clear this stuff over here. And I'm going to play it out and see where he's at with the screen.
So let's set this up as a normal compound interest question. So A equals P times 1 plus I to the exponent N. We know that the amount that he's going to have to pay back is $610.
Remember, A is also the same thing as future value, right? Because A is the future, P is principal, which is the starting amount. So P would also mean present value over here. So he's just using compound interest like we did yesterday. It's the same thing, though.
We know that his original principal that he needed to borrow to buy the TV was $500. We don't know the interest rate, but what we do know is that it's compounded monthly. So if I know that it's compounded monthly, the annual interest rate that I'll have will be divided by 12. Because we're
okay, that's what we got. I divided by 12.
Asked for the annual rate, not the monthly rate. And the amount of compounding periods, because it's monthly, and this is a year and a half. Well, how many months are in a year and a half? Well, there's 12 months in a year and 6 months and half a year. So 12 plus 6 is 18 total months.
Okay, so that's what we got here, right? 1 year It's compounded monthly, so you got 12, and it's for a year and a half, so you multiply 2, you got 18. So that's what he got there. So now he's going to show you how to manipulate to get I by itself.
All right, our goal here is to isolate for I. So let's use backwards BEDMAS to do that. First thing we're going to do is divide away this 500. So 600 divided by, 610 divided by 500. Well, let's get our calculator back out and see what this equals.
I'm going to fast forward because you can kind of just see on the screen. First thing he does, what do? He got 610 divided by 500. And then he got, because that's what you do to get rid of the 500, divide both sides by 500. Okay. Just doing some BEDMAS now, okay?
Just get 1 plus I over 12 by itself and get rid of this exponent 18. So remember, when we have something to the exponent, we have to take the nth root to get rid of that exponent. So we're really taking the...
So what's happening is, if I have this, you have to get rid of the exponent. That's the next step you gotta do, right? So if I have here, I'm to the power of 18. So in order for me to get rid of to the power of 18, I'm going to have to, if you remember the radical, I'm going to have to do the 18th root, okay, on this side, and then this will be canceled. Okay, so watch.
18th root of both sides to get rid of this exponent. So when you're writing this down, it's going to look like this. You're going to put a radical sign.
Okay, he's putting a radical sign, and he's going to have an 18 there. So it's 18th root. Okay, then he's going to show you how to do this in a calculator, because you guys probably may not know how to do this in a calculator. So watch.
And you're going to take the 18th root of both sides.
And then when you do the 18th root of both sides, this 18 is gone, and all you're left with is 1 plus I over 12. But he still has to do the 18th root of this side here.
So we're going to take the 18th root of 1.22. So in my trusty
so now watch on the calculator, because it's important. I don't know if you guys done that kind of manipulation of the math. So watch on the calculator. It's showing you the 18th root.
Graphing calculator, I go to the math option and I pick number 5, which is x to the radical sign. But I guess first I need to put the number that I'm taking the nth root. So 18.
So you put the 18th, and then you can put the square roots of that symbol.
And then
okay, you see the symbol there? That's what you put in the calculator. So 18th, that symbol. The x means it's going to be the 18th root, and then you put the number underneath. I think the number is 1.22, right?
18th root of 1.22.
Okay.
And so I get 1.011108516. I'm going to write down most of those numbers. 1.011108516. And that's now going to equal 1 plus I over 12.
Okay, so now what you're going to do next is going to get that 1 over to the other side. So when 1 goes over to the other side, you're going to subtract 1 from that side, and you're going to get I over 12, right? So I'll just fast forward. You can see 1 goes to that side, it subtracts that. Therefore, you're going to have 0.011108516, right? Right, and then you get I by 12. That means it's going to be 12 times that. And you're going to get i's equal to 12 times that. I's, so that's going to be your interest rate, right? Your interest rate is 0.1333. So that means, that's in decimal. That means it's 13%, 13.33%. Okay, so we write it out.
Is 13.33%.
Okay, so that is figuring out the present value. So now we're going to go into annuities. So we learned about present value. We didn't do annuities yet, so we're going to do annuities. And then we need to figure out present value annuities. Okay, so let's go to present value. Sorry, annuities, my bad. Okay. So this is a different formula, guys, but it's you gotta watch this though.
Over the last few lessons, we have discussed ways in which people have invested money into accounts that are earning interest, both simple interest and compound interest. For all of these examples, though, all we've done is we've put in one principal payment and
So I wanna just basically start off. Annuities is sort of payments, right? So regular payments. So like for example, if I have a pension, right? A pension is an investment. I put a whole bunch of money into my pension. So when I retire, my pension is going to give me regular payments every month, right? Because I invested money into a pension fund, and then now there's money there. And if I want to, live off that money, I need to know, first of all, I need to know how long I need the payment, how long I need to have payments for, right? So if I retire, let's say, I want to live until I retire, I don't know, at 65, and I want to live, and I think I'm going to live till 100. So I should have regular payments that take me to 100, right? So I need to know what those regular payments are, and then I need to know how much I need to have in the beginning in order to know that the regular payments will last me that much time, right? And I need to know, and I want to have a certain amount of regular payments. So I need to know how much I need to put in order to have that. If I want $1,000 a month, I need to know how much to put in order to, when I retire, to have $1,000 a month. So this is what we're talking about: annuities, regular payments. Okay.
let it run for a period of time and then calculated the amount that was left at the end of the period. Interest was accumulated throughout, but in the real world, this isn't really how things work. People don't just put one payment into an account. A lot of times investors will make what we call regular payments. So either every month or maybe every other week, they'll put money into an investment, and then all of those different payments they put in will all add up, but all of them will also earn interest.
Okay. So that's another thing in the real world. When like the last example where the kid said if he saves $775 today, in the future you'll have $1,000. But most people don't do put a one-time savings. Most people, or most, what's the reality is, maybe I'll put $5 every day, or I'll put, $200 every month. I'll save $200 every month, right? That's what we normally do, not this one time and then wait in the future, see how long it grows to. We usually do like frequent payments, okay? And that's what he's talking about too as well.
These types of investments are called annuities. So in this course, we're going to be examining something called ordinary simple annuities, where we make payments at the end of each compounding period. If we compound 12 times a year, then we're going to be making 12 payments per year. Here's a question we're going to investigate first. Colin is awarded $500 per year as long as he maintains a certain average mark for each of his 4 years of high school. He plans to deposit this award at the end of each school year into an account that pays 4% per year compounded annually. So here are the questions we want to answer.
Okay, let's understand that. So it says here, okay, it says here that he's putting $500 down. Actually, he's getting $500 every year as long as he maintains his a certain average. So let's say he maintains that average. So that means every year he's going to get a $500. After year one, he gets $500. After year two, he gets another 500. After year three, he gets another 500. After year four, he gets another 500. But the account pays 4% per year. That means he's getting paid 4% on whatever's in the balance, but the balance is changing every year because every year he's putting another $500 in. So that changes things as far as how we do the calculation. Okay.
Answer. Assuming that Colin maintains the necessary average, how many times will he receive this $500? And will each of these 500 deposits earn the same interest in dollars? So
Okay, so how many times will he receive $500, right? So it says here, the answer should be 4, right? Because after if he maintains that average all the way through, he should get 5 after year 1 it's 500, after year 2 500, after year 3 500, after year 4 500, right? So that's how many times he should receive $500, 4 times.
we're going to see if we can explain the answers to those. After that, we're going to try to determine a method to calculate how much will be in Colin's account when he graduates. Just remember that he will receive another $500 at the end of each year. Well, let's start with question 1a. So it says, assuming that he maintains the average, how many times will he receive $500? Well, if he's rewarded $500 at the end of every year for 4 years of high school, this one seems pretty obvious, but he's going to earn it 4 times.
Okay, so he's gonna get five $400 payments. Okay, and now the question is, will each of these deposits earn the same interest in dollars? The answer is no. They won't receive the same, because the first 500 would be in longer than the last 500, right? If he receives 500 after the first year, that means it's going to have interest on it longer than the last 500 after he gets after year 4, right? So the answer is that it's not going to be all the same.
Now, if we think about it, at the end of his first year of high school, I guess we'll just call that grade 9, he's going to get $500 and put it into an account right away. At the end of grade 10, he's going to earn $500. At the end of grade 11, he's going to earn $500, and at the end of grade 12, he's going to earn $500. Will each of those $500 deposits earn the same amount of interest? Well, I would assume that the amount that he earns, or the $500 that he earns after grade 9, will be sitting in the bank all the way through grade 10.
Okay, he's saying what I just said. The first 500 would be sitting in the bank after grade 9, all the way through grade 10, all the way through grade 11, all the way through grade 12. Therefore, that will get a more interest amount, dollars earned, than the last 500. Okay, so the answer is they're not all the same. So let's see if he writes it down. Okay, he's basically going to show you the timeline. So let's look at the timeline. Okay, so the timeline shows where he gets his $500, and you can see how the compounding interest and how it changes on each deposit. So okay, so there you go. Let's fast forward. Okay, so the interest on this $500 is only that 4%. The interest on the first 500 is going to be more. Watch. I'm going to open it all up so you can see. Right? So the interest, the last 500 doesn't get anything because he just got 500. The first 500 got interest for 3 compounding periods because it's compounded annually, right? So it got compounded 3 times. The second deposit got compounded twice. The last deposit just got compounded once, and then the first deposit, the third deposit, but the last deposit got no interest on it because we're looking at the balance after 4 years. So the balance after 4 years, I would get 500 plus interest, 500 plus interest, 500 plus interest, and then another 500 with no interest because I just got that 500. Okay, so that would be, and then here at the bottom is showing you the future amount after you add up all those 500s plus interest. Okay, so that's what would be in his balance in his account after 4 years, right? Okay, so that's a little bit more because if you think about it, if I just put 500 in each year and don't get any interest, that would be $2,000, right? 5 times 4 is 2, so 500 times 4 is 2,000. right? But I got interest. So my interest is actually an additional $123.23. Okay. So, but now we need to figure out how we can write this in a formula way instead of just showing this chart way. So this is what we're going to do in the next couple of minutes here.
We said it had to be at least 2,000, and so you can see that we earned $123.23 in interest over those 4 years. Now, if we look at this right here, what does this look like to you? Think back to our sequences and series.
Yeah, right. Doesn't this look like sequences a little bit? I start with 500, and then my next one, there is some kind of pattern going on here. There's a pattern here, right? That's what he's trying to get you to look at. There's a pattern in this sequence here, right? I start off with with the 500, then I have the interest with to the power of, this is to the power of 1, to the power of 2, to the power of 3. So there's a pattern coming up here, and that's what he's making you guys see.
Unit. What type of series is this? Well, I guess we can ask ourselves, is it arithmetic or geometric?
Okay. Is it geometric or is it arithmetic? It's not arithmetic because remember, arithmetic meant that between the two, well, you know what? Let's just play the video and let's just go through the explanation.
And so the answer to that is, are we adding the same amount to each term, or are we multiplying the same amount to each term? And as
okay, are we multiplying the same amount to each term, or are we adding the same amount to each term? So this would be term 1, term 2, term 3, term 4, if you want to look at that, right? So are we adding the same amount to each term? Let's see.
as we go from the first term to the second term, and the second term to the third term, notice we keep multiplying a 1.04. So this has to be a geometric series.
Okay, right? Because we're not adding the same amount, right? Because it's 1.04, 1.04. But we're not adding, it's not the same amount. We're multiplying, my bad. I should say we're multiplying. So since we're multiplying, it has to be a geometric series. Now, here's the formula for geometric series if we go back in time, right, from yesterday. And now he's going to tie that into how we can use that to figure out what is annuity, get the annuity formula.
And here's the formula we use for geometric series. So I guess we can come up with a formula to help us figure out how much interest will be result, and what the total amount will be at the end of this annuity based on the formula for geometric series. For our example,
okay, so here we go, right? So here we're looking at the annuity. So here, if you can see the future amount, right, for that student when he was getting $500 every year for getting good grades, this was the formula that we had, right? Right, so it's 500, right? The annuity was the regular payments, that was 500. The interest rate was like what you see there, where I was 4%. And if we sub this into this formula here, which is a geometric series formula, you're going to get something like this. So that's what he's doing, right? He's subbing these things into here. And we're saying A. If you remember yesterday, A was the first term, right? And when we're doing geometric series and arithmetic series, A was the first term. Our first term is 500. So to see how the similarity is, okay? And R, in this case, we're looking at interest, is your 1 plus I. And then N was the term, whatever term we're talking about. We don't know what term yet, but we can say if it's 4 terms, then you can, but this is just showing you just the basic formula. Okay, so watch.
example, our A value was the first term, which was 500. The common ratio was what we multiplied to each term, so that's 1 plus I. And in our example,
right? Yesterday, I know we said I said it was interest rate, which is similar. Yeah, that's interest rate, but it's our common ratio. Our common ratio means what we multiply each term by. Remember, we're multiplying each term by 1.04. That's what we got here. 1 plus the interest rate. So the common ratio was 1.04. Okay, where I is interest.
I was 0.04. And so if we sub those things into our formula here, instead of saying Sn, we can just say A for amount. And so we plug all those numbers in, and this is what we end up with as our formula. 500 times 1 plus I to the exponent n minus 1 all over I. And if we put in I equals 0.04, well, we end up with A is equal to 21.23 and 23 cents.
Okay, so you can see how when we use this annuity formula, which is basically a geometric series, right, we get the same amount. Okay.
Exactly what we had before. And so this leads us to our general formula for an annuity. For any annuity where R represents the regular deposits, I represents the rate of interest, and N represents the number of compounding periods, we can find the future value of an annuity as this equation.
Okay, you see how he switched up the equation, right? Right? We changed A, right? In the previous, I'm just gonna go back a little bit, right? This is where we at, right? We're at 8. Go at 847. Let's back up to 847. Let's back up to 822. Right? So A, right, is in the future, we call it a future value. And the big A I'm talking about, the capital A, right, is FV for future value. And then when we look at the geometric series, that little a was the first term, right? The first term is the value of the first term, which is our first regular payment. Okay, so then this little a became R in the formula for annuities. So I'm gonna go back to which was here. Okay, so R is our regular payments. Okay, which would be also considered the first payment, right? The first term, right? Because it's not going to change. We're going to put the same amount. The kid was getting $500 every month or every year. So that's not going to change. That's not going to change. That's called the regular payments, right? Regular payments. And then I is your interest. So basically you came up with this formula here. So this formula will give you what would be the future amount if we put a certain amount of money in an account with a certain amount of interest, with the determine whatever compounding period that we need in order to get a future amount of money that we want. Okay,
an annuity as this equation: R times 1 plus I to the exponent n, subtract 1, and all of that over I.
Okay, so again, we have the formula now, so now you can just do an example question, right? So look at this question. At the end of each month, so we're talking about month now, right? Yoshi deposits $100 into an account that pays 6% per year, compounded monthly. He does this for 3 years. So it's saying draw a line to represent this annuity, or a timeline. We don't have to really draw a timeline. He'll show you on the screen. We'll use the formula to actually calculate the amount. But if you draw a timeline, it can show you. So after first month, he puts 100, and then you get some interest on that. After the second month, third month, and if we're talking about 3 years, that's going to be 36 months, right? He's doing that for every month for 36 months. Okay. And then it says determine the amount of money in the account after 3 years. That means after 36 months. And then how much interest will the annuity have earned? Okay. So the future value of that account after Yoshi deposits all 36 regular payments of $100, and each one will have a different amount of interest applied to it, because the interest is compounded monthly, and that means that interest of the previous month will get an interest amount. Okay, so now watch. Let's just fast forward, because we need to get a little quicker here. So he's going to do the timeline. Here's your timeline, right? So you can see 36 months. Okay, So now deposit $100 for all these 36 months, right? This $100 here, the first deposit, is going to get the most interest on it because it has to wait. It's going to be in the account all the way for 36 months, right? So it's going to be in the account the longest. So we'll get the most interest. Each of these will get interest, but the first deposit will get the most interest on it, okay? Okay, so he's showing you the timeline. And yeah, it's compounded monthly, so your interest rate would be divided by 12, okay? So there you go, he's showing you like that. You can see here, year month 35, there's like one compounding period. Month 36, there's no compounding period, right? That's just the last deposit, right? Then you're gonna look at, you know, compounding period 34, or month 34, we'll get 2 compounding periods. Month 33, we'll get 3 compounding periods. So month 1 will get 36 compounding periods, right? So let's just look at it. Or sorry, 35, because this is start month 1, we'll get 35. Because it's after month 1, there is 35 more compounding periods left. So month 1 will get 35 compounding periods. So you can see, right? So our regular payments is 100. Our multiple from each one is 1.005, right? So we have all the, and our compounding period is 36, and our I is 0.005. So from there we can calculate using our formula, right? So our future value is going to be equal to this formula, where R is our regular payments, I is our interest, and is our compounding period, right? So that's what you're going to use. And when you plug everything, right, 36 divided by 0.005. Okay, punch in the calculator.
This is what we get.
Okay, he's going to punch that in the calculator. I want to show you, because maybe you need to see that. How does he punch that in the calculator, right? And you need to make sure you don't make mistakes here. I'm punching it in the calculator.
100 times, and then in brackets we're going to put 1.005 to the exponent of 36 minus 1, and then all of that divided by 0.
Okay, you see that? So that's key here. 100 times, this whole thing is in bracket, so you know this is just 1.005, so make sure you just do that. To the power of 36 minus 1, and then the whole thing is going to be divided by the one number, 0.005.
0.005. $3,933.61.
So think about that. Yoshi put $100 every month for 36 months, right? So he saved $100 for 36 months, right? If he didn't get any interest on it, he would have got $3,600, right? Because that would have been, you know, 100 times 36. But because he put it in an account where he was getting 6% interest, compounded annually, compounded monthly, he got actually $3,933.61. Okay, so he got about $333 more because he put it and he invested his money. Okay. Okay. So
That's a ton of cash. Now let's just make
also too, he actually put money away. So that's good that he put money away. He saved money. So in 3 years goes by quick. And if you just put $100 in a month in an account for 3 years, and it's going to give you interest, that's pretty good. All right. So think about that for yourselves. Okay. Let's fast forward because I want to get into the last lesson. It'll be, so there you go. You can see he made $333.61, like I said. Okay. This is another question which is similar. I don't think we need to go through this one because we kind of have the same pattern as before. Okay. Maybe I'll just go quickly. 500. So she needs $5,000 in the future. When she gets, oh, this is a little bit different. She needs, so this is different. Okay. Because it's a little bit slightly different. We're saying what we need in the future. Okay. What we need in the future value. It's telling us we need $4,000 for the future, right? And she graduates in 2 years. So it's telling her timeline is only 2 years. She plans to make a deposit. She plans to make deposits into an account that earns 6.5% per year, compounded weekly. Draw a timeline to represent this annuity. How much should she deposit weekly? So basically we're saying she's going to put money in the bank account weekly. Okay. So we need to figure out how much money she needs to put in the bank account weekly. So what we're trying to do is we're trying to find the R. This is what we're trying to find. We're trying to find the regular payments. What is the regular payment she needs to put in order to get $4,000 in 2 years? Right? With the interest that she's putting it, with the money she's putting into the account, that's going to give her 6.5% compounded bi-weekly. So we know the future amount. We don't know the regular payments. Okay. So, but we know the interest. You know, the interest is I, but it's compounded weekly. Since it's compounded weekly, or sorry, bi-weekly, that means bi-weekly. Well, there's 26 bi-weeklies in the year, right? Because we have 52 weeks. So you divide 52 by 2, that's bi-weekly. Okay, which is 26. So our interest is going to be divided by 26. That's why I'm talking about this. It's a little bit different. I'm going to step through and not play the video because we don't have time, but let's look at it. There you go, right? Our interest divided by 26, like I said. Okay, that's going to be our interest. Okay, it's showing you the timeline. It's compounded bi-weekly. So bi-weekly, the interest is being earned on whatever she deposits, which we don't know yet. Okay, so by the way, when we say 2 years, that means, and it's bi-weekly, she's going to put money in. So that means that she's going to have to do 52 payments, right? Because 1 year is 26 bi-weekly payments. 2 years will be another 26. That's 52. So 52 bi-weekly payments she has to do, which is your R, which we don't know. Okay, so we're going to fast forward. That's the timeline. And basically, because we know what our interest is, we divide it by 26. This is going to be what we're going to need to do our calculation. 1.0625. Right? We know our future amount is 4,000. So let's get into the formula. Right? So our interest, right, is going to be the 0.06. So all this is going to equal to 1.0625 in here. We know what the R is. We know the N is 52 and the I is 0.0625. So that all we have to do now is just isolate R. That's all we got to do here. Okay, there you go. Sorry, I meant to say 0.0025, not 625, 0.0025. Okay, so how do you isolate R? That's what you have to do. and it's going to show you how to do that. You're going to have 4,000 times this 0.0025. And then also actually you can have 1 to the power of 52, okay, minus 1, okay. Actually, you can't minus them because that's going to be, the R is going to be attached to that still. So watch the steps that he's doing. There you go. Okay, my bad. So R is in the big bracket outside. So you're going to get this to the power of 52 and subtract the 1. So now you have one big number here divided by 0.0025. Now you can easily isolate R, right? You can easily isolate R. And we isolate R is going to be, this is the payment she's going to have to do now. She's going to have to put $72.13 every 2 weeks into the account. That gives her the amount that she needs in order to have $4,000 in 2 years. So that's doable, right? So for her to have $4,000 in 2 years, she has to deposit $72 every other week or bi-weekly into the account, right? In order to get the $4,000 that she needs for 2 years at the interest rate that she needs. That's given to her, okay? So we're done with this. We're gonna go to one last, this one should be quick. This is present value, right? Present value annuity. Here we were talking about future value annuity. So we're saying and this one here with the annuity, we need to know what's the regular payment we need to have in order to have something in the future. Okay, in order to have, I don't know, this case $4,000 in the future. So now we're talking about present value is a little bit different, but it's similar. Okay, so this one won't take long. Give me 10 minutes and we'll get this one done. It's just a different formula. That's all we're doing, looking at just a different formula.
We've now come to the very last lesson in our final unit of our course. And in this lesson, we're going to look at what's called the present value of a simple annuity. In the last lesson, we looked at what ordinary simple annuities were, and what they are just compound interest questions where you have regular payments that you put into an account. And a simple annuity is where you start with the present value of 0, and then you add a regular deposit every compounding period.
Okay, so he's summarizing what we did before, right? So you put regular deposits in order to arrive at a future amount, right? So we started off, say, whatever we started off at the first term, and say we want to have $4,000 in the future, we'd have to make regular payments at a certain amount of interest in order to get that $4,000 in the future. Okay. Now we're doing something different. We're trying to figure out the present value of annuity, which is the amount of money needed to finance a series of regular payments. So how much money I need to have in my account now in order for the money to make regular payments regular payments, or in order to make regular withdrawals. Okay, so we're going to get into that example right now. You know what, I'll play it, hear his take on it, and then so we can hear both sides. We're saying the same thing though.
Today's lesson, what we're going to do is we're going to look at examples where you start with a present value, but then you're going to make regular withdrawals away from the account before you arrive at a future value of 0. This is called the present value of an annuity. And
okay, so that's the key right here, right? So we're talking about the present value of annuity. So I need to take out money from the future, all right? Sorry, I need to take out money now so that my future amount is 0. So an example would be, I use my retirement example, right? So if I have, say, $1 million in my account, and I want to use all of my money of the $1 million in 25 years, right? How much regular payments, and I need that to make, to support my lifestyle. What are the regular payments that needs to come out in order for it to last? It's not just straight, just divide out by how many years, but I also am going to have interest inside there, right? So I'm going to have interest in that money. So it's going to go down, but the interest will also bring it back up. So it's not coming down as quick, right? So that's what we're looking at as well.
It uses a different formula than what we learned for a regular simple annuity. Here we have Brad and Angelina, who are about to retire.
There you go. Retirement, right? That's what I was just talking about. There you go. Retirement.
And they're talking with their investment advisor about a good plan to save money for the future. They figure that they can live off of $1,000 a month for the next 20 years. Yeah, not the way they live, but...
You see that? I was saying 25 years. They're saying 20 years. Okay.
Well, of course, if we're talking about the same Brad and Angelina. But whatever. If they invest, their account can earn 9% annual interest compounded monthly. Realistically, that's a lot. So here's question number 1A. How many total withdrawals will they need to make? Well, let's figure this out right away. If they're going to live off $1,000 a month for the next 20 years.
Okay, so how many total withdrawals, right? We can, for the next 20 years and taking $1,000 a month. Each month is 12, it's what? 12, each year is 12 months, right? So in 1 year, they're going to make 12 withdrawals, and then they're saying you're going to live for 20 years. So that means 20 times 12, that is what, 240? That should be about 240, right? Let's see here. 20 times 12, 240. So 240 withdrawals are going to come out of that account. Okay. So that's, and then it says, if we take this number of withdrawals and multiply by 1,000, okay, is that the amount they will need in their savings accounts the day they retire? So the question is, if I multiply 1,000 times, I don't know, 240, that's going to give me what? How many zeros now? That's going to be $240,000, right? $240,000. Would that be enough for them to live in retirement? That's the question, right? So let him let's see how he's going to say it to you. Watch.
Of withdrawals and multiply it by 1,000. Is that the amount they will need in their savings account before the day that they retire? Well, if they're going to take $1,000 out a month, 240 times. So let's take 240 and multiply that by 1,000. Well, that's $240,000 that they're going to be spending over their retirement. Now, is that the amount of money that they need to initially put into their account the day that they retire?
Okay, that's the question. Is that the amount of money they need to put in their account initially, like today, in order to be able to take out 240,000? That's the question.
And the answer is no. Because even though you're taking out $1,000 every month, remember that
okay, the key is, right, they're putting money into an account that's going to give them interest. So the question is, do I need $240,000 now today in order to have $1,000 a month? No, because what happened is I'm going to put 200. If I have money in my account today, right, I'm going to get interest on it, right? So interest will grow over time, over the 20 years. So I don't need I don't need $240,000 right now. I probably need less, because the interest will grow on the money that's in my account in order for me to take out the $1,000 per month. Okay. So I'm going to need less than 240. Okay. Because I'm going to have interest in my money that's in my account, so that when I take out 1,000, then I'll maybe go up a little bit because I have 9% interest. Okay.
initial amount or the present value that you put into this account that you're going to be making withdrawals from will be earning interest. So you don't have to put in $240,000 in the account. You need to put in less. And that money will then,
like I said, need to put in less because that money is going to grow, right? Because it's going to be in there for 20 years.
earn interest into the future, and enough interest to be able to pay off $1,000 a week, or sorry, a month, for the next 20 years. So what we're going to do is we're going to figure out how much money they need to invest today so they have enough to pay that $1,000 240 times. Let's first start by creating a timeline to model what the withdrawals look like.
Okay, so it's going to show a timeline. Let's kind of fast forward to the timeline. Okay, so this is the withdrawals, right? So month one, right? I'm taking out $1,000 a month. Month one, here's my withdrawal, right? And month, and then this is my compounding. I think it's compounding period is it monthly? I think it said monthly. Let me just double check. It's compounding monthly. Okay. So if it's compounding monthly, so the money that I take out, the first 1,000 I take out only got compounded by 1 month because it came out already, right? The last 1,000 that I take out was in there for 240 compounding periods, right? So we got the most interest on it. So that's why it's 240 to the power of 240. The first one's only the power of 1 because it's only there for 1 month and I take it out. The next one's in there for 2 months, then I take it out. So it's 2 compounding periods. So that's the timeline, right? And so this is what I'm taking out each month. Okay. So let us go back just to the beginning of that to explain that. You can see up here, present value equals to future value divided by the 1 plus the interest in the compounding period. Okay. So my present value is okay, so let's look at it from here. I don't want to confuse you. I'm going to play it from here and we're going to play through the timeline.
Look like. And here we have it. You can see at the top of the timeline we have our compounding periods. So if we start with today or now, we're going to have 1, 2, 3, all the way to 240 different compounding periods. And each of these periods is a month. So these are all in months. Each compounding period, instead of making a deposit, we're actually now making a withdrawal. So we're going to take $1,000 each compounding period. But what we want to know is, how much is this $1,000 that we're going to need to pay out in the future worth to us today? Because that's the amount that I need to save today for each of those $1,000 withdrawals. So just like we made the timeline in the previous lesson, we're going to do the same sort of idea, but now bring the money backwards to today. So this first $1,000 withdrawal 1 month from now, we're going to bring it back to today. And if we remember our present value formula, it's equal to the future value divided by 1 plus I to the
Okay, so the key is we're looking at this formula here, right? Let me use red. Okay, this formula here. Oops. Let me move this over here. And oh, it's not working for me. There you go. What the? Okay, let me just fix that. Okay, so we're looking at that formula, right? But we can rewrite that formula. I'm just going to write it here so you can see it, right? So we're looking at what's the present value. The present value is going to equal to the future value, right? And I'm going to put times here. 1 plus I to the power of -1. It's the same thing, remember? Here and here, the same thing, right? So my present value is, I don't know. what my present value is, right? But I know my future value is I'm going to take out $1,000 in the future, divided by or multiply by this interest multiple here, right? In the future, I'm going to take out 1,000 and I'm going to multiply it by this. So the present value we don't know, but the present value is what's going to be in the account, okay? And that's what we're trying, what's going to be in the account is what we're trying to figure out. And the future amount, we already know the future amount is going to be $1,000. They're going to take out $1,000 every month, okay? So I just want you to get that in your head. So that's what we're doing here, right? Right? So we're taking $1,000 times this future times this interest rate, okay? And if you multiply this out, this will show you what we would have in the account, right? But then we have to have all these things added together to get what's the actual amount in the account. Okay, so I want to get that there for you to set that up. So let's continue.
Exponent n. So the future value of this withdrawal is 1,000, and I'm dividing it by 1.0075 to the exponent 1. Well, where did we get 0.0075? If we remember, the interest rate was 9%. And because we're compounding monthly, we're going to divide that by 12. And this equals 0.0075. The withdrawal that we're going to make 2 months from now, well, to find the present value, I'm going to bring that back to total.
Okay, I'm going to fast forward a little bit. So he's doing each timeline. Okay. So, okay, so now we get down to the bottom. So from this time, we can find the present value, right? We can find the present value by adding up the present values of each withdrawal. Okay. Now, because we're trying, if we add up all of the withdrawals, and which will give you present values, then if we add them all up, then you'll know what the present value for each withdrawal. Okay, now watch. Let's back up. He's gonna explain it right here.
Will need in their account is equal to all of these things added together. So all those things added together creates this. Well, it looks as though it's a series, right? This is
okay. So again, looks like it's a series, right? So the total, my total present values is all these withdrawals added together, right? So, and we're saying the withdrawal at this time, right? At that compounding period, all the way to the last compounding period. If I add them all together, those are all the total present values, right? So the present value, remember, is this divided by the 1,000. 1,000, we know the future value is, it's 1,000. So if I add up all these present values, I get the total amount of present value. That would be the amount I would need in my account today in order to get $1,000 from my account in the future. The total amount today. Okay, so let's do that. Now he's turning, we're going back into our series formula, right? That we picked up from before. Okay, so let me clear this up on the screen. We're almost done, guys. I think we got like 2 more minutes, and then we're gonna just end it here. Okay, here is the formula that you're gonna use, right? In order to get the present value, you need to look at the regular payments. Okay, regular payments is R, which is $1,000, and what is my present value that I need in order to have $1,000? So let's go through this. Yeah, don't ask me, guys. Let's focus on what I'm talking about right now. I'm not gonna you're gonna get it back today, okay? Don't worry, you'll get it back today. Thank you for asking, though. And you'll get Unit 4 back by Monday, or no, this weekend. Okay, so that answers 2 questions: Unit 3 test, Unit 4 test this weekend. Unit 4 by the end of today, you'll get Unit 3. Okay, let's focus on getting this done.
before, I could put this into the geometric series equation.
So I'm going to fast forward to just get into the actual example now, because we have the formula. That's the total present value. Okay. So what we're doing here is, I guess, answering the question now, right? The question is, how much money that she needs to have in the account now in order to take out $1,000 every month for 20 years. Okay, so here's the answer.
So the present value that we'll need equals our regular withdrawals, which was 1,000, times 1 minus.
Okay, so he's going through the formula, and then what we need to have in our account is going to fast forward to the calculation. We know that by now. Okay. So what did we say the person needed? Well, it says here the person only needs $111,144.95. So the person needs only that much in order to take out $1,000 a month for 20 years, right? And remember, we said it was going to be less, because if you do the math, if you say $1,000 a month times 20 years, well, that's $240,000. But we're saying you don't need $240,000 to save in your account right now. All you need is $100,000 and $100,000 and $111,000 and $144.95 in order to take out $1,000 in the future. Because this amount is going to be in accounts where you're going to get interest that's compounded monthly, and that interest is 9%. Okay, so that's your answer.
Withdrawals over the next 20 years. That's pretty good savings. That's less than half of the amount of money they're going to be paying out. So just know that when you retire, this is the same idea exists here. You're going to get a chunk of retirement money when you retire, and you're going to be giving yourself a bunch of money every month. And the amount of money you start with, remember, that can get earn interest over time, and you'll be able to actually take out a lot more money than what you initially have there as your present value.
Yeah. Okay. So that solves there. I don't think I need to go through an example. The example is just basically you plug in these formulas. Okay. I won't even go through this. This is just a retirement. She has $300,000 savings when he decides to retire. He invests in he invests in annuity that will pay him for the next 30 years. So he's going to put money into something that'll pay him, that will give him money they'll pay him every quarter. So every quarter means every 4 months he'll get money for 30 years. And that account is going to pay him 5.2% interest compounded quarterly. Okay. That's Jay-Z. Actually, Jay-Z's making more money than that. But anyways, so I won't even go through this. You already have the formulas, and you can come up with the calculation. This stuff is on the quiz that's today. Okay, so the quiz that's today, this is on there. I believe this is also on these things, the annuities and stuff like that. This is also on the collimating. Okay, remember, let me make this something clear to you. Okay, I'm going to close this right now to make it clear to you. Give me a second. I don't want you guys to. So we'll go back to the home page now. We finished the lesson. Okay. When I show you here the collimating, this is part A. Okay. That means there's another part to the collimating. This is only part A. Part A is due. I know someone's going to say, oh, it's something it said on the 23rd. You know what? I want it due on the Monday, 11:59 p.m. The reason why is I'm going to give you part 2 or part B. And if you guys are still struggling and thinking that there's only one part, then you're not going to have enough time to do part B. Part B, I'm going to have it open on Tuesday. So I want to make sure you guys are done part A because part A and part B is the last thing you have to submit. And if you take forever to part A and you don't have enough time for part B because you think I have a whole, that's why I want to make sure you guys submit part A by Monday, 11:59 p.m. I only put the due date there because some people just, for whatever reason, take longer than normal. Okay. You can scan. Okay. For the column A, we're talking about part A. So I don't know what you're talking about. We're talking about part A. Part A is written, right? You can't fit onto one. Yes, you can. All you have to do is take. So guys, I feel like you guys are not like, okay. In order to, maybe I have to show you. I'm gonna have to show you. Okay. Yes. So listen to what I'm saying. Okay. You're writing it on paper. Yes. Doesn't matter if you're writing on paper. So you're gonna take a picture of it, right? Everybody, listen up. When you guys are doing, there's multiple ways to create a PDF, right? You can take a picture of your test, okay? And I want to show you a video because I feel like maybe I need to show you that video. And some of you guys never got that video, and some people are struggling, right? So this is going to be pulled up. Okay, so let me go to Loom. I think I have it in Loom. Okay, here it is. I'll just show you. That's what I'm going to show you right now, right? Because I feel like I thought you guys would know how to do this, but apparently you don't. I'm going to show you. I created a video here. It's playing. Let's see.
Okay, guys. So this is a video just to show.
So again, this is me recording my video I showed you to some people. So everyone should know how to create a PDF, right? You can take your pictures, post it in Docs, and let's watch.
Show you how to submit something from Google Docs, convert it from Google Docs to PDF, and to insert your images, right? So here, first of all, I want to make sure the title makes sense. If this is an application question that you're submitting, so type in application up top, or if it's a thinking, do the same. So now go into insert, go to image. You can grab it, from any of these areas here, but maybe it's best to grab it from your computer if you were to take those images, download it on your computer somehow, and then from here, upload it from your computer and paste it onto here. So this is just an example of an image I just pasted. Okay. You want to maybe format it so it actually fits. So you have to resize it so it fits.
Okay. I'm pausing. So Anthony, that's okay. That works for you? That's how you've been doing it for works. That's again, you can make different pages, right? You can add like 20 pages into this Google Docs, right? Okay.
And now I'm gonna go to the next line.
Sorry.
Okay, I need to maybe do more than one page, and I'll paste another image. Maybe it's the next question. Okay. So once I do that, then the next thing I want to do is I want to export it as. So when I go to export, I need to go to download. So I'm going to download it as a PDF. Okay.
So again, I can paste 20, like I can take 20 pictures, right? Maybe I have 20 questions. I can take 20 pictures, paste it, all the questions on this one Google Doc, okay? Because people keep saying I can only submit one. And I'm trying to tell you, you can submit, yes, you can submit more than, you don't have to. Okay, but I just want to make sure everyone understands because I get this email, people saying I only can submit one because that's all you need to submit. You don't need to submit 20 files. All you need to do is make one file through Google Docs and paste all the images. So you have 20 images for 20 questions for your column mating. Paste it all here, 20 questions. make one file like it's showing you here.
So I click on download PDF. Now my Google Docs is going to be downloaded as a PDF. Okay, so I have it there as a PDF. I go to where it is on my computer, and you can see there it is. So now I have this Word doc. I'm going to double click on it. Sorry, I have this PDF, and there you go. Here's my PDF. Okay, now you can submit that into.
Okay, guys. You guys, I'm gonna stop sharing. You guys all understand how to submit now? Okay, so I don't want to hear, I don't know how to submit. I can only submit one file. I know you guys are here. You guys are probably the ones that don't need this message because you already heard the messages. A lot of people are not on this call, so they're going to be the ones wondering how to submit. Okay, so please submit your test for today. It's due, like I was saying, all on annuities is due today, and the collimating that's open, it's due on. I'm emphasizing Monday at 11:59 p.m. midnight. Okay, is what a test? What's a test? What are we asking? Is what a test? Let me share my screen because you're asking if something is a test. What is a test? Right? Right? We have a collimating, right? Collimating part A. You're gonna get part B next week, and then you also have a quiz today based on what I talked about on the simple interest and annuities. These are things you have due today, and the collimating is due on Monday. Okay. Helena, does that answer your question? Helena, you asked the question. Does that answer your question? Okay, good. Okay, if there's no more questions, you guys can go ahead and start your day and get as many things. And again, I'll get you back your unit 3 quiz today, or unit 3 test today, and the unit 4 test you'll get on the weekend. Okay. Okay, guys. Have a good day. Bye.